know exactly what the square root of 26 is, but is there a number next to the square root of 26 that you do know?
25.
25. You know what the square root of 25 is. The square root of 25 is 5. So, I mean, you can make a guess that the answer to this is going to be really close to this, right? Okay, so we're gonna use derivatives actually to help us estimate what this is going to be, what the square root of 26 approximately equals. And so let's pull the function out of this. This function right here, let's define it. We're going to say f of x equals the square root of x. And pretty much what we got going on here is we know, if we made a table, we know pretty simply that if I plugged in 25, we would get 5. But we don't know what we would get if we plug in 26. And this example says estimate this value. Estimate this value. So let's take it a step farther. If we think about the square root function, it looks something like this. And let's pretend that 25 is right here and 26 is right next to it. Now 25 would give you a value of 5. 26 would give you a value slightly above 5. So that's what our answer is that we're looking for. We're looking for what is this y value. So keep that in the back of your mind. We're looking for a y value right now. Okay, here's another function. Okay, this is a linear function. Now, if I took the derivative of this linear function, do you know what I would get?
You get a point.
You guys know what we would get? It's a line, so that means the rate of change is constant. Which means that every single point on this line right here, you would have the same rate of change. In other words, you would have the same slope because it's linear. Here's the equation for it. And I just made this up, so let's see, 3x and then plus 1. There's the equation for it. Take the derivative of it. What do you get? The derivative of this is just 3. It's a constant. It doesn't change. Everywhere on this line, every point on this line is a 3. So if I were to plug in, let's say I plug in 1. Do you guys know what I would get for this function, or this little equation? If I plugged in 1, I would get 4, right? I would get 4. Okay, what if I were to plug in 2? 7. Okay, so how is this 3 related to what just happened right here? It just went up 3, right? Okay. Well, what if I didn't change a whole number? What if my change in x, what if my delta x was not equal to 1? Let's say that my delta x was equal to 0.7. So what would 1.7 be? Now this went plus 3. What would this be? If I start at 4, what would I get for 1.7? And how does that relate to the 3? I mean, last time we just added the 3, right?
Yeah.
But that's because we had a whole unit of change. Now we only have a 0.7 unit of change.
Multiply it by 0.7.
4, yeah, 4 plus, not 3, but 0.7 times 3, right? I don't know. I'm just thinking off the top of my head here. This is your delta x, and this would be y prime. Okay, you guys still with me?
Yeah.
We're going to see this again in a second here. All right, so I just wanted to do off to the side. Let's come back to this guy. I can estimate what this value, what 26 is going to give us by using our slope. Now this slope is a little more complicated because it changes. Not like this one right here. It's constant. It's a 3. Boom. It's super simple. But you guys know how to find the slope for this. Let's see. If I took f equals square root of x, or f of x equals square root of x, if I took the derivative of this, f prime would equal, let's see, I'm thinking x to the 1/2 power right here. We would drop the 1/2, we would multiply it times the x, and then we would take that 1/2 and we'd take 1 away from it. And so f prime would equal 1 over 2 square root of x. There's our f prime. So what is the change at 25? If I want to know the change, like what is the rate of change at 25, how is the line changing? We would just plug it in. Right? And what do we get? It's a really simple number. 1 over 10. So this is our 3 from over here. Now over here it was more simple because it's going to be 3 no matter where we go. The change at 1 for this equation is 3. But over here the change at 25 for this equation, this function, is 1 over 10. And look at that. We have, what's our delta x? What's our change right here? Just 1 unit, right? So therefore we can just say our estimate is 5 over 10. Or 5 1/10. Sorry, I said that wrong. Which is the same as saying 5.1. So what just happened, I went the long route to explain to you guys how to use the derivative to help us estimate what this is. So this 5 1/10 is this number right here, this question mark. So what is the square root of 26 actually? So if I go second, do my square root, plug my 26 in, boom. Is that number close to our estimate? It's a little less than our estimate, which is to be expected because if we were to look at our line, it's getting less and less steep, right? And so it would be slightly under our estimate. Okay, so what about 27? Let's take this a step further. We already solved this problem, but what if we were asked to estimate 27? Here, take a minute and see if you guys can give me an estimate of what you think the answer might be. So last time, our change in our x, our delta x, was just 1. But now, going from 25, we have delta x that equals 2. So how many changes should we be adding to this 5? 2. So you would get 5 2/10, which is the same as 5 1/5. So this is our estimate. What are we doing here? We're estimating a y value. There's 2 things you guys can do in this section. This section is titled linear approximation. We're using a tangent line to estimate the next values. A tangent line tells you the change that is happening at that point in time. A tangent line is linear. Linear approximation, we can use that to approximate a y value or approximate the change in the y. Okay, the change in the y is just going to be the derivative. So let's write some of these things down. Okay, so if we were to estimate the change in y, now I'm putting f, but it's the same as y, the change in y, if we were to estimate that, all we need to do is we need to take the derivative at the a. Now in our case, our 25 was the a. The a is like the number that you want to plug in because it's simple. Okay, the change in a, and then you multiply it times the change in x. Or you can say the derivative at a times the change in x. This will give you an estimate of the change in the y value. What if I just wanted to estimate a y value? That would be approximately equal to f of a plus that. F prime of a times delta x. And that's what we did. We did this right here to find 5 1/10. We found the slope at 25, which is this right here. Multiply it by 1, which we didn't really do because it's the same thing. And we added that, which was 1/10, to f of a. And f of a, in this case, was 5. Or you can see it right there. So this is how you estimate the y value. This is how you estimate the change in y.